Welcome to Physics Power. So now we will discuss about Rutherford atomic model, that is planetary model. We can also call as Rutherford nuclear model. Why? Because Rutherford gave the clear picture about the positive charge of the atom that is located at the center. He only called that is as nucleus. So before going to complete details about the Rutherford atomic model, just one small recap of Rutherford alpha scattering experiment. So he did an experiment by taking alpha particles and those projected on gold foil. He gave some conclusions. Let us see the conclusions once. So those are: first one, according to his experimental observation, he observed that atom is almost empty. So he gave the statement: reason, without deviation all the alpha particles are crossing the gold foil. Very few are just scattering with more than 1 degree, that is just 0.14% out of all. So with that he able to give the details about positively charged, and as well as for negative charge he gave some details as a theory. So that is Rutherford atomic model. So according to his conclusion and according to his experimental observation, he concluded that is the first one, the atom is a neutral body, but at the center it is having positively charge. So that is heavy, that entire mass contribution to the atom by nucleus only, means due to positive charge only entire atom is having mass. So the due to negative charge that mass contribution is very less as compared with positive charge. Okay, so that heavy positive charge located at the center of the atom, and he named that is as nucleus, and that nucleus size is very less. Why? Because according to his alpha scattering experiment, most of the particles crossed the gold foil without deviation, very few are deviated. So very few deviated means that positive charge located at very thin space, so it took very less space to occupy. So with respect to that he analyzed that the size of the nuclei, that it is order of just 1 Fermi, that is 10 to the power of minus 15, but atom size is 1 angstrom unit. So with that he gave conclusion, that is the size of the atom is 1 lakh times more than the nucleus. Okay, so not only that, so here entire mass, most of the mass, not entire, so most of the mass contribution by positive charge and located at the center, and it is occupying very less space. With respect to that he mentioned that the density of the nucleus is very high, that is 10 to the power of 17 kg per meter cube. That much high density is there that he analyzed. And this is about positively charged body. Then what about negative charge? So to give the complete picture about atomic structure, so about positive charge from his experiment able to say complete details, but about negative charge he did not have any experimental evidence. But atom is neutral one, that he know. So he first thought that around the nucleus positive charge electrons are distributed at different places. But with respect to that he got one out: if electron is there at a particular place near to the nuclei, then nucleus is very heavy and total positive charge, and electron is a small quantity of negative charge. So easily that electron here, these electrons easily can be attracted towards the nuclei. So all these electrons should attract and all electrons should attach to the nuclei. So that is not happening. So with respect to that he got one idea: why can't we adopt planetary motion? As like planets revolving around the sun, similarly here also electrons are revolving around the nucleus. For that he considers circular orbits. Actually according to planetary motion, planets are revolving in elliptical orbits. He did not consider elliptical orbits, but Later on, after his theory, Bohr theory is there. After Bohr theory, some drawbacks covered by Sommerfeld by taking elliptical orbits. So if we consider here elliptical orbits, so Sommerfeld unable to explain his theory. So Sommerfeld also got space to explain. So as it is, he did not compare. He considered circular orbits according to his present problem solution. He want to give the complete picture. For that, he considered only circular orbit in such a way that electrons are revolving around the nucleus at different places with different radii. Electrons are revolving, and that velocity is in such a way that due to circular motion, outward centrifugal forces will come, and as well as that will be balanced by nuclear attractive forces. Means how much electrostatic attractive force is there in between nuclei and electron, nucleus and electron, same quantity of centrifugal force will act outward. So here from the nuclei attractive force, electrostatic attractive force, and due to rotation of the electron, outward centrifugal force will act. So both will balance. Electron will revolve in circular orbit with a fixed radius. That he concluded. So about positive charge, from his experimental base he able to give clear picture, and as well as about electrons also he gave the details. So not only that, here if you go to further theoretical analysis, so regarding alpha particle experiment, further he gave the details theoretically. That is, so here with these points we able to conclude that atom is having positive charge located at the center of the atom and electrons revolving in circular orbit. Okay, so some complete perfect approach he able to give with respect to his experiment, and further with alpha particle experiment he made some statements also. Those details: first one, distance of closest approach. As alpha particle projected towards the nuclei, so that electron, you can observe, coming close to the nuclei, it can come up to a particular distance only. It cannot come up to the surface of the nuclei. Why? Because both are positively charged particles. So initially the alpha particle, whenever it is at a long distance, it will have more velocity. So let it be initial velocity, but as it is reaching the nucleus, that velocity will reduce continuously and finally it will become 0. So initially it is having more velocity and finally the velocity becomes 0 at a particular point. So according to the conservation of energy, we can say the total kinetic energy converted into potential energy at a particular place. Okay, so kinetic energy of alpha particle total converted into electrostatic potential energy between nucleus and the alpha particle. So with that, here that alpha particle came very close to the nuclei. So how much distance it can come, that is called the distance of closest approach. So for that he did one derivation also. Let us see that one. So here kinetic energy of alpha particle and the potential energy between nucleus and alpha particle both are equal according to conservation of energy. So here kinetic energy of alpha particle means we can write half mv square here, and according to the statement, just a minute, according to electrostatic potential energy, the potential energy between the two charges, that is 1 by 4 pi epsilon naught into q1 q2 by, here b is the distance between the two charges. Here our concept is distance of closest approach, so that distance is b. Okay, so now let us see further. Kinetic energy and electrostatic potential energy both are equal, we equated, and further here q1 let us consider that is the charge of the nucleus, and q2 let us consider it is the charge of the alpha particle. So here nucleus consists of protons and alpha particle is nothing but helium nuclei. Later on they studied and they identified alpha particle nothing but helium nuclei. So helium consists of 2 protons. So each proton charge is E, then 2E. So Q2 charge is 2E. For example, we consider a particular atom. So that atomic number is Z in that case. So if you know the atom, then we can write that value. So in general Z is atomic number. So Z number of protons are there. So Z is the charge. So Q1 nucleus charge, that is ZE, Q2 alpha particle charge 2E. If you substitute both, then distance of closest approach equals to ZE square by 4 pi epsilon naught into mv naught square. So here if you substitute the both, here ZE into 2E, 2 divides for 2 times, and left side right side denominator 2 get cancelled. Then if you shift this B towards left side and remaining all terms if you keep right side, then B equals to ZE square by pi epsilon naught mv naught square. Okay. So but the same expression we can also mention in another way. At first, for example, here kinetic energy term if you keep as it is here without writing this one, then here it will be K, then just substitute only Q1 and Q2 values, then right side part ZE 2E this will come, but here it will be only kinetic energy Ke. So then if you reshuffle both, then denominator Ke will come and B right side denominator it will go to left side. So B equals to 2 ZE square by 4 pi epsilon naught into Ke. So like that he derived expression for distance of closest approach. So with this we can conclude one thing: if kinetic energy of alpha particle is very high, then distance of closest approach is very low, means that alpha particle can go very near to the nuclei. But if kinetic energy of alpha particle is very low, then inversely proportional, B is very high. So distance of closest approach is inversely proportional to kinetic energy of the alpha particle. That he concluded with his derivation. Next, impact parameter. So here that impact parameter word you can observe here also in this diagram. So simple definition wise, impact parameter is a distance. It is a perpendicular distance between initial direction of alpha particle. Let us consider one alpha particle, for example, coming like this. This is the initial direction of alpha particle. If we extend the direction of alpha particle like this, and here you will get a shortest distance. The shortest distance nothing but the perpendicular distance between the initial direction of alpha particle and the nucleus is nothing but impact parameter. It is a perpendicular distance. Okay. And as well as one more thing we should know, that is scattering angle. Scattering angle nothing but we project the alpha particle towards the target nothing but gold foil, but finally it went in another direction. So the angle between initial direction and final direction of alpha particle we can call as a scattering angle. Like that he introduced one physical quantity, scattering angle, for this concept. And finally, for the number of alpha particle which are reaching the ZNS screen, for that he able to derive one formula, that is Rutherford scattering formula. So that is very much bigger one in higher studies, means generally for example who is raising +1 +2 students, for those this derivation is not required, but it is the important derivation for degree students. Okay. So now I don't like to go for entire derivation, just I want to give one detail about the number of particles reaching the ZNS screen. So here for numericals point of view you should remember this: the number of alpha particle crossing the ZNS screen and reaching the gold foil, that is inversely proportional to sine of the fourth power of the half of the scattering angle. So, that is his analysis. So, according to Rutherford scattering formula, we can take this formula also. So, this is about Rutherford scattering experiment, and with that what he gave the details about Rutherford atomic model. Thank you.